Hi, hello everybody. So this is section 9, and it's our second part of this video dealing with section 9, which is factoring the greatest common factor. And we'll also see on the next video factoring by grouping. So this is the beginning of the different techniques dealing with factoring. The greatest common factor technique, which we abbreviate as GCF, is the most important one. So we'll take a look at two problems here, and then I'll go over, just as in the previous videos, how to do some of those problems posted here. So take a look at problem 915. We have the expression 18x cubed y squared minus 27x squared y. So when we have to factor the greatest common factor, we have to think of two things. Number one, there may be a number that is common to both, in this case, both terms. So we have to look at number 18 and 27, and we'll ask ourselves, what is the largest number that can divide both 18 and 27? Okay, so for example, 3 divides 18 and divides 27. So when we divide 18 by 3, we get 6. When we divide 27 by 3, we get 9. However, 3 is not the greatest common factor between 18 and 27 because there is a larger number that can divide both 18 and 27. And that number is 9. So we divide 18 by 9, we get 2. We divide 27 by 9, we get 3. So anything larger than 9 does not go evenly into 18 and 27. Okay, so the greatest common factor means the largest possible number that divides a set of numbers. So we have to find the numerical greatest common factor. And in this case, I have two types of variables. We have X and we have Y. So I have to find the greatest common factor among the X's, and I have to find the greatest common factor among the Y's. Now, for the variables, it's very easy because all that we do is we find the variable among the like variables. For example, among the X's, we find the variable with the smallest exponent. So between x cubed and x squared, the greatest common factor is x squared, the smallest exponent. Between y squared and y to the 1, the smallest exponent is y to the 1. So as you can see here, for the solution of 915, the term 9 squared y in both typeface is the greatest common factor. So when we do that, after we find that, we will divide each of the terms by the greatest common factor, and the result will be inside of the parentheses as your final answer, as you see here, 2xy minus 3. All right, so this is in essence what it is to factor the greatest common factor. If there is a minus in front of the number of the first term, we'll factor the minus out as well. And we'll see that, when I do a problem later on. Okay, there's another type of greatest common factor that happens when we have, as you see here in problem 917, we have two terms, and each term has a parentheses expression, and inside of the parentheses expression, we have the same identical factor, x plus 8. So when that happens, that becomes the greatest common factor. Okay, so we'll factor the x plus 8, and in the second parentheses, the two terms that are outside of the parentheses will be included in the second parentheses. So this type of greatest common factor, binomial factor, is very easy to do, and you'll see later on when we'll do examples dealing with that. All right, so let's take a look at the three problems that I'm going to do. Problem 920. So I have three terms right here, 10x4y squared, 25x squared y cubed, minus 15x squared y. So as I said before, the first thing that we do, we have to find the greatest common factor among the numbers. So I have to find the largest number that can go into all three numbers. So the very first thing that comes to mind is 5. Yes, 5 goes into 10, goes into 25, and goes into 15. Perfect. Is there anything higher than 5? So for example, 10. 10 goes in here, but does not go into 25 evenly, meaning there's a remainder, and it doesn't go into 15 evenly. So 10 is out, and anything larger than 10 won't work. So the greatest common factor, the numerical greatest common factor is 5. So we'll write it here. Now, I have to find the greatest common factor among the x's, right? Because every expression has an x, and then every expression has a y. So that's very easy because I have to check x4, x squared, and x cubed. And as I said before, the greatest common factor is the variable among those type of variables with the smallest exponent. In this case, x squared. So take a look at the y's now. What do you think the greatest common factor for the y's is? Yes, y to the first or just y. So we'll write it here. So this is the GCF, or greatest common factor, for the expression above. When you find that, open parentheses, and inside of these parentheses, I need to have 3 expressions. Okay. And I'm going to do the work on the outside right here. So this is what you're going to do. You're going to rewrite the original expression as I'm doing right here. And if on the final exam you have a question like this, you will do the same. You are going to divide all 3 expressions by the GCF, greatest common factor. You're going to get an answer for all 3 of these. And the answer, the 3 terms that you're going to get, you are writing it inside the parentheses right here. And that's it. So here we go. First case, 10 divided by 5, 2. x4 divided by x squared. Remember properties of exponents. This is the quotient rule. X squared, right? 4 minus 2. Y squared divided by y to the 1. Second one, 25 divided by 5, 5. X squared divided by x squared, they cancel. Y cubed divided by y1, 3 minus 1, 2. So y squared, positive. Right? Minus 15, third case, third expression, minus 15 divided by 5, minus 3. X cubed divided by x squared, x to the 1, or just x, right? 3 minus 2. And both of these y's cancel. So this is my answer after the division. This is what you're going to write inside of the parentheses. And this expression right here is your factored expression, okay? If you wanted to check that this is correct, you can FOIL it as we've done it in the previous section, and you would get back the original. So this is all there is to factoring the greatest common factor. All right, let's take a look at another problem. This is 922. And it's simpler than the one before. I only have 2 terms, but now I have a minus as my first term. It's okay, no problem. We apply the same technique. I have to find the GCF between minus 20 and minus 15. So minus, and now focus on the number. So the largest number that can go into both 15 and 20 is still 5. I look between the x squared and the x cubed. The smaller one is x squared. And I look between y cubed and y, and the smaller one is y to the 1. Open parentheses. Same as before, I am going to rewrite this expression here now, minus 20 x squared y cubed minus 15 x cubed y. And I'm going to divide each one by the GCF. Okay. The result of each will go inside of the parentheses. So let's do the division. Minus 20 divided by minus 5, 4, right? Minus divided by minus is a plus. The x squares cancel. Y cubed divided by y1 is y squared. Remember, quotient root 3 minus 1. Minus divided by minus is a plus. 15 divided by 5, 3. X cubed divided by x squared, x to the 1, right? 3 minus 2. And the y's cancel. So this expression, 4y squared plus 3x, will go inside of the parentheses. And this is your final answer, the factored expression of the original problem. So it's very straightforward if you remember the steps. Okay. Let's see the last example. And this is the case where you might have a binomial factor. So notice, I have two expressions, this one and this one. There's an invisible one here. Notice that this term is identical to that. So when that happens, this becomes your GCF. All you have to do is open a second set of parentheses. And this is very easy now. The terms that will go in here are the terms outside of the parentheses. So in here, what are we going to write? AB minus 8B minus 1. And this is your factored expression. So a case like this one is extremely easy. Likely that you're going to have this on the exam, maybe final. And it doesn't take more than 15 seconds to do. All right, so this is the technique, the first technique of factoring called factoring the greatest common factor.